Hello students, your physics teacher Hassan Darwish with you. Remember in the last video 2 about chapter 4, we verified that the motion of the horizontal elastic pendulum without friction is simple harmonic motion, and x equal a cosine omega 0 t plus phi is its time equation. Clear? So the motion. But what are a, omega 0, phi? First point, omega 0 squared is equal to k over m. Remember? This is y double prime plus omega 0 squared y equal 0. Okay? That's the first point. So implies what? Omega 0 equal square root of k over m, right? This is called angular frequency. Why it's angular frequency? Because here it is in the angle of cosine, okay? This is time. First point, a and phi are constant of integration. Clear? Arbitrary constants. Now what are the physical meaning of the two constants? Let's explain why. Let's take the absolute value of x. Okay, but don't forget x represents the distance or the position from O to G. So absolute value of x represents the distance from O to G. Don't forget this. Clear? I mean the distance from the equilibrium position to the center of mass of the body. So I can write it as a cosine omega 0 t plus phi absolute. Now a is always positive, so I can write it in this form: a times absolute cosine, etc. Okay? Now you know that amplitude, as we defined it in video 1, and you know from last year and the year before, is the maximum displacement, right? From the equilibrium position. It means what? Absolute value of x maximum, which is equal what? Now what is the absolute value? What is the maximum value of cosine or sine? You know from mathematics it is equal to what? To 1, right? So this becomes a times 1 equal a. So implies the constant a in mathematics represent the amplitude of oscillation in physics. Clear? The amplitude of oscillation. And phi is called initial phase. Means it gives us about the initial excitation of the pendulum, how you started the motion of the pendulum. That's why we call it initial phase. Means the phase at t equal to 0. We use the condition at t equal to 0 to calculate the value of the angle phi. Okay? So usually we write the equation in the form x equal xm cosine or sine, it doesn't matter, okay? Omega 0 t, which is radical k over m, plus phi, okay? This is the time equation of simple harmonic motion in the case of rectilinear motion, okay? Here it is. Now you know that. What is the period of motion? Period, you know that. Omega 0, the angle is equal to pi over period. We call it W0 and here T0. So T0 is equal to pi over omega, means to pi over radical K over M. And this will imply equal to pi root M over K. So you have to keep in mind this rule. The proper period, T0 is called the proper period or natural period. You know, in periodic motion, the proper period is a period for one oscillation or one cycle. Remember? Now the proper frequency, as you know, F0 is equal to 1 over T0, right? Now the graph of X, you know this from mathematics, the graph of cosine or sine. Let me draw it here. Here. Sorry, not clear. This is the time axis as an abscissa axis, and this is the function x. Now you know the period is, the graph is something like this. The sinusoidal curve, don't forget this. Sorry. Etc. So here is the period from maximum, okay, to maximum. This is T0, or this is, here it is. Okay, we have to erase this part because the amplitude is constant. So this is the proper period. And you know this is the amplitude, right? Let me use the green or blue color. This is the amplitude, xm, okay? Or this value, the same, okay? Fine. Let's do a direct exercise. In our experiment, the block is shifted by -5 centimeter and then released without velocity at equal to 0. Knowing that the mass is 200 gram, K 20 Newton per meter. Calculate omega 0 and determine the values of xm and phi. You may solve in your textbook the following exercises, okay, as a homework. So let's do it. First we have x equal xm cosine or sine, it doesn't matter, okay? Omega 0 t plus phi. Now you know that point 1 omega 0 equal radical K over M, which is equal to radical K is 20 and mass 200 gram or 0.2 kilogram. Then you get radical 100 or 10. You know this is like theta prime, radian per second, okay? Now we want to find xm and phi. The two constants as known in mathematics, arbitrary constant in mathematics, are determined by applying the initial condition always. Clear? So determine xm and phi, we have to apply the initial condition. Apply the initial conditions. What are the initial conditions here? Here you have to say at equal to 0, initial abscissa is how much? Minus 5 centimeter, and the initial velocity equal to 0. Look at them, here it is. That's the initial abscissa, and this is the initial velocity without initial velocity, okay? Good. So abscissa, the function is given, but you need to find the velocity. You know that at any t, at any time, v represents the derivative of x, which is x prime. Let's make derivative for cosine. What's the derivative of cosine function? Cosine u, it is minus sine u times u prime, remember? So xm, what's the derivative of cosine u? Sine u omega 0 t plus phi times what? U prime, derivative of this. So it is omega 0, okay? So quickly, we get the two functions, x equal xm cosine omega 0 t plus phi, and v equal x prime, which is minus omega 0 xm. We've just made the derivative, remember? Sine omega 0 t plus phi. Let's apply the initial conditions. We get minus 5, which is x0, equal xm cosine phi. I replace t equal to 0. Don't forget here, t equal to 0. And 0 equal minus omega 0, which is 10, xm sine phi. Here also I replaced what? T equal to 0, okay? Now let's solve this system of equation, which containing two unknown, xm and phi. It's very easy to solve the second equation, because you may say, use this equation, use this. Sine phi is equal to 0 over minus omega 0 xm equal to 0, right? So you get sine phi equal to 0, but under what angles sine is 0? Under phi equal to 0 or phi equal 180 degrees, means pi radian. So you want to know which one is true. You have to replace in equation 1. So you can replace, if phi, if we choose, or if phi equal to 0, then what do you get from this equation? Minus 5 equal xm sine 0. Clear? You get xm negative. So xm negative rejected, because the amplitude is always positive. So if phi equal pi, then you get what? Minus 5 equal xm. Here, sorry, we have cosine 0, cosine, not sine in the equation. Cosine pi. And then you get cosine pi is minus 1. So xm equal plus 5 centimeter. This is equitably. Hence, we get the time equation. X equal xm, which is 5 centimeter. You get it in centimeter if you like. 5 cosine 10t plus pi. And here is the time equation of this pendulum. Okay? Take care. Bye-bye. See you in the next videos.